Hey, it's Miss B, and in this video we are looking at Unit 4, Lesson 6 of Illustrative Math Algebra 1. So let's look at our first question here. We're given a graph, and this graph represents Andre's distance from his bicycle as he walks in a park. So using this graph, we are now going to decide whether the following statements are true or false. Okay. So this says the graph has multiple horizontal intercepts. Now, a horizontal intercept is where the horizontal axis is either touched or crossed by our graph. And I do see, as I traced along it, I see one here on the left and one over here on the right. So looks to me like this is true. So we are going to say true. Part B, a horizontal intercept of the graph represents the time when Andre was with his bike. Well, it's his distance from his bike, and that would mean that his distance is at 0 at that time. So I would agree, and I would say that this is also true. A minimum of the graph is 17, 1. So let's look at our graph here. 17, 1. Now, a minimum would be the lowest point this graph goes. And so they're saying 16, 17, they're saying right here at this point is a minimum. Now, I see a point really close to that, but it looks more like it's right here, not quite at 17. And it's not completely a minimum either way because my graph does dip lower at both of these horizontal intercepts on the left and the right. So it's not exactly on 17, and there are also other places lower on this anyways. So we're going to say for this case that this one is false. Part D says this graph has two maximums. So a maximum would be the highest point on this graph. And if we just look at it from here, it looks like we do have two sort of bumps, but let's actually look at these closer. So you can see we have this line here, and it appears that this bump that looks like it happens at 9 seconds actually lands right here along this horizontal line. If we keep this going, you can see my horizontal line actually passes through 2 points on our other bump. So this one actually does go up higher, about right here. And it looks like from there it kind of just curves downwards again. So this really only has one maximum because it's definitely above this line here. They look very, very close, but there is a visual difference. And so this graph has two maximums. That is false as well. Now, question E is asking us to interpret some seconds and distance. It says about 21 seconds after he left his bike, he was the farthest away from it at about 8.3 feet. So let's look here. I'm going to use my laser pointer at 21 seconds. That looks like it was the maximum we had identified before. And it says about 8.3. So from 21, we go up here. Let's draw this over. This does look like it lands very shortly above 8. So yeah, we can say that's true. 8.3, sure. And so we are going to say that yes, this statement is true. And that's question 1, just interpreting some information about that graph. Let's look at question 2. The graph represents the temperature in degrees Fahrenheit as a function of time. Tell the story of the temperature throughout the day. Identify the maximum and minimum of the function and where the function is increasing and decreasing. So your answers are going to be a little different here than mine. And that's okay, because you get to tell the story of the temperature throughout the day. But I'm just going to give a generic or an example response. So let's see, the temperature increases over time, right? It's going up until about 3 p.m. and it hits its highest point, and then it looks like my temperature is going down. So we can say from the morning, from the morning, the temperature increases until 3 p.m. After 3 p.m., it decreases until about 9 p.m. And there's not much actual data I can put in for what the temperature is, because my temperature on the left-hand side of my graph doesn't actually have numbers. So I can't give numbers. But if you want to add a little more detail, you can say at the temperature at the beginning of the day and the end of the day is about the same, because I can't draw a straight line very well, but they look about the same to me. If we look at them going straight across, that line's a little better. We can say the highest temperature is at 3 p.m. Just so that we have something in there about a maximum. Now, this doesn't really have a minimum specifically, because technically, if it looks like at the beginning of the day and at 9 p.m., the temperature is about the same amount, then we have multiple minimums. So we talked about where the function's increasing and decreasing. We identified the maximum. That was 3 p.m. We said where the function is increasing. Yes. Where the function is increasing. Yes. Where the function is decreasing. Yes, after 3 p.m. Minimum, we can say the lowest temperature is the same at the beginning of the day and at 9 p.m. So the beginning of the day, since they don't give us a time, 12, that looks like around 9 a.m., but I'm not comfortable estimating that, so I'm just going to call it the beginning of the day. And we'll add another sentence in here because we do want to talk about the lowest temperatures. So the lowest temperatures occurred at the start of the day and at 9 p.m. So even though I don't have specifics, I can still put in a little bit of a description. So minimum, oops, didn't want to cross things off there. Minimum, I think we have a sentence now that addresses our minimum. All right, so that's questions 1 and 2. Let's look on the next page. Here we have question 3, and then we have questions 4 and 5, which are our review problems. I do want you to try your best on these, even though some of them might be a little funky or require a calculator, like with question 4 here. But let's look at question 3 first. So for question 3, we are to match each feature of the situation with a corresponding statement in function notation. Okay, so we're not putting anything on our graph here, but our graph is what we're using as our data. What we are going to look at is A, B, C, and D, and then matching those with 1, 2, 3, and 4. So I'm going to draw some lines matching them up, but I'm also going to write the letters next to the numbers over here on the right. So like this might be A or something like that. So let's find these things. Maximum height. Well, it looks to me like the very tallest this goes is right here. So we have to be careful because we have time and we have height. And they wanted to know the maximum height, not the time. So the maximum height here is going to be 16, and it occurs at 4 seconds. Now, do I have something here telling me that's 16? I don't. But I do actually have h of 4. And h of 4 altogether represents the output value at 4 seconds. So it's being a little bit tricky here with us because it asks for height and then it's only giving us input, but maximum height, that's going to occur at 4 seconds. So this one is A. Now, minimum height, where's the lowest point that we have? Well, we have our starting and our ending height. It looks like our lowest height is right here. That looks to be around 2, and it looks like it happens at 1.5. So again, if we look at our options, we don't have 2, like the height, as an actual option here, but we do have the height at 1.5 seconds. And the height at 1.5 seconds is the lowest height. So that is going to be our minimum. And so this is B. Now the next segment is where the height is staying the same. And I do see a little section over here. So I see a section here where my height is staying the same, meaning the output value is constant or it's flat. And that's between 7 and 8 seconds. And they're actually telling us, it's right here, 7 to 8 seconds for time. And then they're actually telling us that it is a height of 6. And this does line up with 6 on our graph. So this one is C. It's a little bit of a giveaway because we have to have two time amounts here for it, but if you're not used to it, that can also make it a little tricky. All right, so last one. Always with the last one on anything that's matching, I always like to check anyways in case I messed something up. So starting height, let's check and see if h of 0 equals 7 matches for starting height. Well, h of 0 would be the height at 0 seconds. 0 seconds would be my start. And is the height 7 at 0 seconds? Looks like it to me. So I would agree, yes. And so this one is going to be D. And that's all for question 3, just matching some of those up, but it's a little tricky seeing some of that notation sometimes. Let's look at question 4. So we have 3 functions, f of x, g of x, and h of x. They want us to compare which values are going to be the largest if we have 100 as our input, if we have negative 100 as our input, or if we have 1 over 100 as our input. So we have 3 different values here for parts A, B, and C, but they're asking us to compare which one is the largest out of all of these. So f of x equals 4x minus 5. So we're taking our input, multiplying it by 4, and then subtracting 5. For g of x, we're doing things in a little different order. We're actually subtracting 5 from our input value and then multiplying that amount by 4. And then for h of x, we're actually dividing our amount by 4 and then subtracting 5 from that. So I'm actually going to switch over to my graphing calculator here, and we're going to look at these different things potentially in a table. All right, so here I have all three functions typed into the Desmos graphing calculator. You can see this graph of them on the right-hand side, but I'm going to use this table function on the left. So I was able to create a table out of all three of these, and I'm just going to put in the input values I want for x for each one. So for part A, that was 100 for each of these. Now my guess, before even looking at these, because I haven't looked, my guess would be that function f is going to be the greatest. And 100. And it looks like I was right, because h is the smallest. That's because we're dividing, and dividing will make larger numbers smaller. And with g, we're actually subtracting before we multiply. So instead of just subtracting 5 from that 400, we actually subtracted 20. So let's then compare if we had, I think our second option was negative 100. Now, if we're looking at which is the greatest, my guess for this one is going to be h, because when we're talking about biggest, negative matters. And if I have something negative, anything that is less negative or anything that's actually positive will be a bigger number. So if we put negative 100 in here and negative 100 in here, we can see which one is actually true. And yeah, out of all three of these, negative 30 is the furthest to the right if we put all of these on the number line. And that's how we're going to say that it's larger. I know our very last one was 1 over 100. So let's look at that. So if I go to my first one and I put in 1 over 100, I get negative 4.96. Now, I actually didn't give you my prediction before this, but I do think these are all lines. I do think, well, this one might be a little close because of the negatives and because of the fractions. Now, if we're taking a fraction and dividing it by a fraction, that is actually going to make it bigger. So there is a chance that h down here actually is larger in this case. So we'll find out together. This would be the same as me plugging it in a calculator. I just like the visual. So I hope you enjoy the little table layout on Desmos as well. Okay, so that one gave us negative 19. So just out of these two, the first one is actually larger, this negative 4.96. Because we actually got a number so small that we were just subtracting 5, and it didn't make much of a difference. So it's pretty close to 0, or it's actually really close to negative 5. Now let's look at the very last one. What are we going to get here when we put in 1 over 100? I get something incredibly close to negative 5, but still technically smaller than f. So there was a chance, but that ship has sailed. So in this case, we have a couple different results. So let's go back to our assignment and put those in. So I'm going to say over here that we have, what did we have for our first result? We had our first result was that f of 100 was the largest. For b, which function value was the largest, that was actually, so h of negative 100, because it was actually the one that was closest to 0, even though they were all negative. And for our third one, it was very close between f and h, but f was again the largest. because it was the least small, or the least negative. All right, let's look at our last one, which is number 5. Function f is defined by the equation f of x equals x squared. So x squared means, just as a side note, this means x times x. The 2 basically tells us take that number and multiply it with itself 2 times. If it's at x to the third, I would have x times x times x. So they want to know, what is f of 2? Well, we would say f of 2 equals 2 squared, and 2 times 2 is 4. What is f of 3? Well, that would be 3 squared, and 3 times 3 is 9. Explain why f of 2 plus f of 3 is not equal to f of 5. Well, because 4 plus 9, and let's actually look at what f of 5 would be. This is going to be 5 squared, and 5 times 5 is 25. So this is not equal to 25. I'm going to use that as my explanation. 4 plus 9 is not equal to 25. 4 plus 9 is actually 13. And that is the end of this assignment. We did only have one page front and back. So hope this helped. Again, this was Unit 4, Lesson 6 of Illustrative Math, Algebra 1.